Hello everybody. Today we're going to learn some about symmetry. Now, we've already heard about symmetry since elementary school, but it turns out there's two types of symmetry. The first type of symmetry is also called reflectional symmetry, and that's where you need to draw a line of symmetry, an imaginary line that passes through the center of the shape, and when you fold it, the ends should meet. So you've divided the shape into two identical halves. So just as a quick review, please draw lines of symmetry on each of these pictures, just real quick. Okay, so you have to be open to all the possibilities that lines of symmetry open to you. In this case, we have to go through both the vertices and the middle of each side. Trapezoid, not as useful because it only has one line of symmetry. You can only fold in half that way. And then the equilateral triangle, passing from the vertex of one shape to the middle of another side. So that is reflectional symmetry. Today I mostly want to talk about this type of symmetry called rotational symmetry. So rotational symmetry has to do with rotating the object. So how far can you rotate the object until it matches exactly what it used to be? So spinning the object around its center, we can determine its order. So there's several things we can figure out about it. The first thing is the order. The order tells us how many times within one full rotation do we have an exact replica, exact copy of our shape. Now the magnitude is going to tell us exactly how far you need to rotate your shape in order to get a copy. So since one full circle is 360 degrees, you just need to take 360 degrees and divide it by the order. That's the relationship between the magnitude of rotational symmetry and the order. Now let's just look at some examples to get started. Got a warning sign, a stop sign, and then this shape. You can kind of think, if you're holding your finger on the center of that object and spinning it around, how many times does it match up itself after one complete rotation? So you might see that it's got three main parts to it. So you have a chance to match up three exact times. So that is going to be in order of three. And therefore, we should see a magnitude of 360 divided by 3, which is 120 degrees. So every 120 degrees we rotate the object, it's going to look the same. Next, with an octagon, we have 8 sides. Even if the stop sign is upside down, it's going to look the same. So every single time, each side is going to correspond to a copy. So we have 8 times where it matches up on top of itself. An order of 8, and then a magnitude of 360 over 8 is going to tell you every 45 degrees we have a match. And lastly, this object. This one's a bit tricky because of this weird pattern in the corner. This one actually only matches up one time. You have to rotate it fully back for it to match up again. Because since this corner is different than all the others, it makes it so the order is much smaller. We have an order of 1 and a magnitude of 360. Some more vocabulary for you is a regular polygon. A regular polygon is a shape where all the sides are the same length. And for a regular polygon, you can know that this fact is true. The number of sides of the polygon is equal to the order of rotational symmetry. So whether it's an equilateral triangle, which has 3 sides, that's going to have an order of 3. An octagon, an order of 8. A hexagon, an order of 6, etc. So let's look at these patterns and determine their order and magnitude. For this one, I see 4 distinct parts to it, and they're all the same. So I should see it match up on itself 4 times as I rotate it around. So this will have an order of 4 and a rotational or magnitude of 90 degrees. And next with the trapezoid, it's only going to match up 2 times in that entire rotation. So after you turn it 180 degrees around and then all the way back around is when you'll see them match up. So that's a magnitude of 180 degrees. Now let's look at this app. This shows us 5 different images and we're going to be able to rotate them. So I'd like you to write down your best guess for images 1 through 5. Give me the order and the magnitude of rotational symmetry. All right, now that you have guessed it, I will reveal the answers. So this is a pentagon with 5 sides. It should have an order of 5, and its magnitude should be 360 divided by 5, or 72 degrees. Now I'm going to adjust this bar to show you how that works out. Once I get to 72 degrees, the pentagon looks exactly the same. Then another 72, that would be 144. Matches up again. And I'll do one more where we get to about 216. That's where the pentagon works. Now with image 2, that shape, it looks like it has 2 equal sides to it. So we should see a coincidence twice in there. So that's an order of 2. And therefore, every 180 degrees, we should see a match. There we go. Moving on to image 3, it looks like it has 3 repeated parts to it, or 3 wings. So that should have an order of 3, and the magnitude should be 360 divided by 3, or 120. So as we go around, 120, then 240, and lastly 360. Image 4 is just like that trapezoid, the parallelogram that we saw last time. It's going to have an order of 2 and match up twice. So that's a magnitude of 180. That's the minimum amount you have to turn it for it to match up again. And lastly, image 5, this looks like an isosceles triangle. It's only going to match up once. You would have to rotate it around the entire time. That's actually called an order of 0. When 360 degrees is the only option you have, then it does not exhibit hardly any rotational symmetry. Okay? And now with these patterns, we're going to determine their order and magnitude of rotational symmetry. We have a 5-pointed star. Each point is the same, so we should have an order of 5 here. Again, the magnitude is 360 divided by that, 72 degrees. Next, a 6-pointed star. A 6-pointed star has those 6 equal parts, so I should see an order of 6. Next, the magnitude is just 360 degrees, or a full circle, divided by how many times it repeats itself. 60 degrees. Next, this flower. The flower has 5 identical petals. So we can have 5 times it repeats itself, or an order of 5. Our magnitude is just 360 divided by 5, or 72 degrees. So every 72 degrees that we rotate this object about its center, we should see an exact replica. And then lastly, this is a 3-legged object, and all the legs look identical to me. So it's going to be an order of 3, and the magnitude is just 360 divided by 3, or 120. So just pay close attention and make sure that each part is identical, and figure out how many times it should match itself when you rotate it 360 degrees.